Hello, I'm Grace Wilson.
And I'm Abhishek Shankar.
And in this video series, we're going to show how you can use LiDAR data to perform 3D object detection. We're going to go through all of the steps of this workflow, from importing and pre-processing your data, labeling it in preparation for deep learning, actually training a neural network, and deploying your network to hardware or other projects. By the end of the series, you'll have a trained neural network that can detect objects from incoming LiDAR data. But for this video, we're going to focus on importing and pre-processing.
Grace, before we begin, can you explain what a LiDAR is?
Absolutely. LiDAR stands for Light Detection and Ranging. It's a type of sensor that's used a lot in autonomous systems and robotics, like for autonomous driving, drones, ground robots, and more. It collects data by sending out beams of light and measuring how long it takes for those beams to come back to the sensor. And by doing that, it figures out where various objects are in 3D space and creates something called a point cloud. This can be helpful in situations where it's extra important to know the distance, size, or layout of objects near your robot, because that kind of information can be measured directly from the point cloud.
Great.
There are two different ways that LiDAR point clouds might be stored, either organized or unorganized. In unorganized point clouds, you have an m by 3 array, where m is the number of points that you have, and 3 stores the x, y, and z coordinates for each point. In an organized point cloud, which is what we have, you have an m by n by 3 array, where m is the vertical resolution of the LiDAR, n is the horizontal resolution of the LiDAR, and again, the x, y, and z points for each point are stored in the 3 channels. For spaces where the sensor doesn't detect anything, so light is sent out but nothing comes back, that is stored as NaN, or not a number, instead of coordinates.
That makes sense.
Yeah. In addition to the point cloud data, LiDAR will also collect intensity data, which is just a measure of how reflective each point in the point cloud is, or how much light was returned to the sensor. Different objects and different types of surfaces might be more or less reflective, so this is just some extra data that can be helpful for something like object detection. The data that we'll be using for this series was collected from a simulated parking lot using Simulink 3D animation. We were able to customize a parking lot to contain some objects that we're interested in training our neural network to detect, stick a LiDAR on our simulated car, and drive it around the simulated parking lot, collecting data along the way. This video series is designed to work for LiDAR data, both real and simulated, but if you're interested in learning more about how to collect simulated data, check out the documentation linked in the description. Now that we understand the data we're working with, let's dive into MATLAB. We're going to explore our point clouds using something called the Lidar Viewer app, which can be opened from the Apps tab or by typing Lidar Viewer in the command window. Once the app opens, you can import your point cloud data. We have a folder of PCD files, so this is the option I'm going to select.
But you can also see that there are a bunch of other options that you can select. So if you have your point cloud stored in different file formats, you can choose LAS or PCAP or even a ROSPAC file if that's how you've stored your data.
Go up a level and select parking lot. Once your data is loaded, we can see the first frame of our point cloud data. Since we have a folder of point clouds, you can go through them using these arrows, kind of like a movie player. And this brings us all the way back to the beginning. Now, there are a lot of options in the LiDAR Viewer to change the way you explore your data. And I like to start by increasing the size of your points, because it just makes it a little easier to see everything as you go through exploring your data.
It does look better now.
Yeah, absolutely. You can also change the colors that are being shown in the viewer. So right now you can see, if you go to color, we're using Perula, which starts at blue and goes up to yellow, but we can change it. Let's say I want to use red to blue, and that's going to say that the red is our low values and blue is our high values. And right now we're measuring our Z height, so that means that red is going to be lower, closer to the ground, blue is going to be higher off the ground. But you can also change what you're measuring, such as radial distance or distance from your LiDAR or the intensity. But I like sticking with Z height because it helps me visualize how tall our objects are in relation to each other. You can also use some of these built-in views to change the way that you're looking at your data. So this is the default. We've got kind of an angle from above. But let's go to bird's eye view, which will go right on top of your LiDAR. And I'm using the scroll to zoom out. And we can see we've now got a top-down view. You can also use some of these options up here. So let's click the hand to pan, to move it around, or to zoom in and out. And we can rotate. So let's say I'm interested in getting a side angle, a custom side angle. We can use these options to do that. You can also, if you maybe move around, you've got a specific view that you've set up for some objects in this point cloud, and you think that it's going to work well in the future, you can save your view. So I'm going to save this beautiful angle that I've set up here. I'll call it my view. And now we can maybe try out some of the other views, chase view, following our ego view, and then we can go back, maybe restore the view. We want to work from afar again, and then you can go into your saved views and click my view, and it'll bring us back to that fun angle we set up earlier. Another way to visualize and learn more about your point cloud is to perform clustering, which is a type of algorithm that attempts to group points that are close together into clusters, which in an ideal world is one cluster per object. So if we view clusters, and let's go back to our default view, and if we view clusters, we can see some of the objects here. We've got some distinct trees in the middle. These cars, let's zoom in, are distinct. But some of these trees here, we're getting a lot of colors, a lot of overlap. And that tells us a little bit about the density of our points and the distance of our objects. Because clustering gets a little tricky when there's too much overlap in our objects. And maybe for these trees here, the leaves are overlapping between the trees. Maybe there's not a lot of points because it's a little bit behind the LiDAR. So that just tells you a little bit more about the separation of your objects and how easy or difficult it might be to identify those as individual objects. If we wanted to learn more about how clustering affects our data, you can go in and check out the settings. You can choose what kind of clustering is being performed. So right now it's range-based, but there's some other algorithms built into here. And you can change some of the settings, like how far away the points need to be considered an object. And the settings are going to be different depending on what kind of algorithm you're using. So feel free to test out these different algorithms and see how your data separates into different clusters. And let's restore our view. Now, we've talked about a few different ways that you can explore and understand your data, but the Lidar Viewer also lets you edit your data, and we're going to take some time to do that. If you move to this Edit Point Cloud tab, we'll talk through a few of these options, starting with cropping. Now, cropping is important because we're only interested in objects that are within a certain distance of our LiDAR. So if we look at this point cloud, we can see that some of these trees and some of these objects are pretty far from our robot. So we're going to use the crop feature to only keep the data that we're actually interested in performing detections on. And that's going to be helpful later on because smaller point clouds will mean faster processing.
And that's especially important in robotics because you don't have a big processor to handle all the data.
Absolutely. When you're working with hardware, you need to be mindful of your memory constraints. So these are the values I'm going to use to crop this point cloud because these are relatively standard values for a front view crop of a point cloud for object detection, but feel free to look into other options for cropping your data. Since we have a whole folder of frames, you can choose to apply this crop to all of your frames. And if you hit apply, it will crop every frame of point cloud data that you've loaded into the viewer. Now, because our data was collected from a simulated environment, it's pretty clean, so that's the only processing we're actually going to perform on this data, but we're going to talk through a few other common algorithms that you might want to use when working with your own data. Starting with denoising. Now, the real world and real world data can get messy. Maybe some bugs were flying around, maybe some light was returned that shouldn't have been. It's just a real world sensor can be a little messy. And so denoising is going to attempt to go through the point cloud and remove any points that don't necessarily belong to objects, so noise. And just like with our other algorithms, you've got some settings that you can change to affect how the denoising algorithm performs, but we're going to leave that. Another option is downsampling. Now, we mentioned earlier that especially when working with hardware, the amount of memory you're using matters. And downsampling is going to attempt to go through your point cloud and evenly remove some points so that you can still see all of the objects, you can still see all of the important information that your point cloud is storing, but just so that it takes up a little less memory. And you can change how much it's keeping or how much it's removing. So I see here it might have removed a little too much information for my comfort. So let's say we actually want to keep 60% of our data, and it'll update so we can see the preview. This makes me a little more happy, so I might choose to keep that amount. But again, depending on how dense your data is, you can choose what works best for you.
So we want to reduce the density, but also have enough information to recognize objects and get all the necessary information.
Absolutely. It's a trade-off of making sure that the point clouds aren't taking up too much memory, but that you're preserving all of the important information stored in our data. Last, we're going to talk about ground removal. So these blue rings that you're seeing here are the Lidar detecting the ground. It's sending out beams in that direction, and it's receiving beams that look like these rings. And for object detection, that's not usually helpful. We're not performing ground removal because our cones are pretty small, pretty close to the ground, so we just want to be absolutely sure we're not removing any data from our cones. But for applications where you're detecting larger objects, or maybe your LiDAR is positioned differently, this can be helpful just for cleaning up your data. And if you preview, we can see that those blue rings are gone, but we can still see our cars, our trees, and other objects. Amazing. There's a few other options in here that I encourage you to look through, but that's all we're going to cover in this video. Once you've performed some processing steps that you're interested in, you can export your point cloud from the Viewer tab. I'll choose Parking Lot Edit because that is the modified point clouds, and hit OK. Now, if we go back, we can see we have a Parking Lot Edit folder containing our cropped point clouds. Let's say you might be collecting more data later and you want to save these steps for reuse, or maybe you just want to learn a little bit about what's going on under the hood when you're performing these steps. If you go back to the Edit Point Cloud tab, you can actually generate a function that'll perform all of the steps that you performed on your data set. And it'll open it right in MATLAB, and it'll contain some comments and some code that'll recreate those steps. So this is good to save in case you want to recreate these steps later.
So since we just did cropping, it has all the limits that we just entered, and this script only has code to perform cropping.
Yep, but if you perform downsampling or ground removal, that'll come in here too. The last thing we're going to show today is this Measurements tab. I mentioned earlier that point clouds store data in 3D space, and you can actually take measurements from your point clouds to learn more about the distance, maybe size of the objects in the data. And that's especially helpful if you were not actually there when the data was collected. So it'll just give you an understanding of the scale. So let's say I want to know the distance between this car and this car. We can see it's about 9 meters if we measure it that way. 7 meters if we measure it that way, and lots of other measurements. So you can see the location of something, and it'll give you the coordinates, whatever you need or whatever you're interested in.
This is great, especially since this is a simulated parking lot. It gives us an idea of the scale of the lot because it's hard to tell from just a simulated environment.
Absolutely. Especially if we want to make sure that when we use this on real data, the scale is similar.
Yeah.
And that is the Lidar Viewer app. So, to recap, some key takeaways. The Lidar Viewer app enables you to interactively explore a point cloud dataset, and it also enables you to modify and pre-process point clouds while being able to see the output of each setting in real time. Last, you can export code from the Lidar Viewer app for later use or learning. The code used in this video is available on GitHub and FileExchange and can be found in the description of this video. If you have any questions or you want to learn more, please check out these resources and feel free to reach out to us.